Solve the proportion. A proportion is when you have one fraction equaling another fraction. And when you see this, it's a very simple method called crisscross applesauce. You take any diagonals and multiply them together. So 4 times r is 4r. Set it equal to the other diagonals multiplied together. 7 times 5 is 35. Now I have a one-step equation. Divide both sides by 4. And it looks like you're going to get a decimal here. You can write it out as a fraction, but you know what? The decimal's not that bad when you divide by 4. 32 divided by 4 is 8, so 32 and 3 more is going to be 3/4 or 0.75, however you want to write it out. But that's how you do proportions. Crisscross applesauce. Solve the proportion. A proportion is when you have one fraction equaling another fraction. When you have that, the method is very simple. Crisscross applesauce. Take any two diagonals and multiply them together. Now, since down here you have b plus 9, I'm going to write it out so that I have b plus 9 in a parentheses so I remember to distribute. Okay, after you do one set of diagonals, you put down that equal sign, and then you multiply the other set of diagonals. So 6 times b plus 5, and again, I'm going to make sure I put b plus 5 in parentheses. So this is a little more involved than a previous problem that I have, a previous video, the video right before this, where I have to do distributive property twice, and I'm going to have b on both sides of the equal sign. So 4 times b is 4b. 4 times 9 is 36. That's going to equal 6 times b, which is 6b, and 6 times 5, which is 30. Now I have variables on both sides of the equal sign. So why don't I do this? Why don't I subtract 4b from both sides? Because I like to keep my variable positive. It's not necessary that you do it this way. I'm just doing it. Okay, try and stop me. That gives me 36 equals 2b plus 30. B is not by itself. I have 30 in the way and I have 2 in the way, so I'm going to subtract 30 from both sides first. Okay, cross that out. 36 minus 30, I'm going to write that up here. 36 minus 30 is 6, and then now 2b is all alone on the right side. Divide both sides by 2. Divide both sides by 2. 6 divided by 2 is 3, so I'll move that over here so I can move the b to the left. And then the end, b is 3. And if you wanted to check your work, you could do 3 plus 9 is 12. And 6 over 12 is a half. Cool. And 3 plus 5 is 8. And 4 over 8 is a half. Cool. And a half is a half. Cool. And I'm done. State if the polygons are similar. So I have two pairs that I'm going to do. In order to make sure that both polygons are similar, you have to do two things. You have to make sure that all of the sides are proportional. State if the polygons are similar. So I have to check if these two are similar, and I have to check if these two are similar. It's two things that you're looking for here. You have to make sure that all of your sides are proportional. That means if I have a quadrilateral, I have to make sure that one fraction equals another fraction equals another fraction equals another fraction. Okay, and I do that with corresponding sides. So I would do like 10 seems to match up with 15. So 10 over 15 and so on and so forth. And I have to make sure that all of my angles are equal. Okay, so the angles have to be equal. The sides have to be proportional. So let's do the proportional part first. I'm going to match up corresponding sides and I'll do small to big. All right, I'll do small to big. So I'm going to see if 10 matches up with 15, so 10 over 15. And I'll go clockwise here. See if that matches up with 14 over 21. 9 plus 10. See if that matches up with 10 over 15. Again. And I have to see if that matches up with 14 over 21. Now, notice a lot of these are repeats, so I don't have to overthink that. But now I simplify fractions. 10 over 15 is 2 over 3. 14 over 21 is 2 over 3. 10 over 15 again is 2 over 3. 14 over 21 is 2 over 3. So the proportional part checks out. Now I have to make sure corresponding angles are exactly the same too. So 90 matches up with 90, and 90 matches up with 90, and 90 matches up with 90, and 90 matches up with 90. So the angles are good, the proportional's good. These two are similar. Okay? Now, let's do this again over here on the right side. Let's start out with the proportional sides first. So let's do small to big again. So we'll start at the top and work my way around regular clockwise. 7 over 21 has to match up with 5 over 15, which has to match up over 7 over 21 again, so I'm not going to rewrite that, which has to match up with 5 over 15, so I'm not going to rewrite that. If you're figuring this out, if you see repeats, just be lazy. 7 over 21 is a third. Cool. 5 over 15 is also a third. Cool. We're in good shape there. Proportional yippers. Now I have to make sure the angles match up. Now I'm not given a ton of information about the angles, except that is 40. This corner is going to be 40. And up here, that corner is going to be 130. But what it tells us is these guys are parallelograms. So whatever this angle is, the angle right next to it is going to be supplementary to it. In other words, 130 and this angle have to add up to 180, which means U would be 50, which doesn't match up with 40, which means no, these guys are not similar. So kind of tricky, because it looks promising with the proportional sides part, but then the angles are like, nah, I'm going to get you. The polygons in each pair are similar. Find the scale factor of the smaller figure to the larger figure. All right, so the scale factor is basically a ratio of small to big. This is the smaller figure. This is the larger figure. I put B for big, not L for large. Don't know why I did that. But too late. Biggie Small is the rapper. So we have to pick sides that are absolutely corresponding. So since I have 18 and 18 and 30 and 30, then I can choose 18 from the small and 30 from the big. Because this 18 lives in between 18 and 21, this 30 lives in between 30 and 35. So that 18 matches up with that 30. So 18 over 30 can be simplified if I divide everything by 3. Or can I divide by 6? I can divide everything by 6. If I divide the top and the bottom by 6, that gets me 3 over 5. So some people might allow you to put the scale factor as a fraction. I think usually in geometry, it's given to you as the word 3 to 5. Or depending on a different book, maybe it might give it to you as 3 to 5. It really all depends. Either way, we're doing small to big, so 3 to 5. If it was big to small, then it would be 5 to 3. But again, depending on whatever book you use, all of these work because it's all telling the same story, 3 to 5. The polygons are similar. Find the missing side length. Whenever you're being asked to find the missing side length of similar figures, you're going to want to use proportions. It doesn't matter which way you do it. I always like to make my proportions big to small. And then what you do is you make a proportion where you do corresponding side over corresponding side equals corresponding side over corresponding side. So if I look at this, 12 matches up with the 6 on the small. So I'm going to say 12 over 6. That's going to equal, I don't know, on the big one, so I'll put an X, over 5 on the small one. Now what we have here is a proportion. A fraction equals a fraction is a proportion. And the way you do a proportion is you find a diagonal and you multiply them. This is called crisscross applesauce. So I could do 12 times 5, which is 60. Then you put the equal sign there. And then the other diagonal, 6 times x, is 6x. Divide both sides by 6, x equals 10. So the missing side length over here is going to be 10, which makes sense because 5 over 6, 10 over 12, 10 over 12 simplifies to 5 over 6, so everything seems to work out on the math side of it, which I'd hope so. The polygons are similar. Find the missing side length. Now, in a previous problem, I was only given 2 pieces of information. For example, I was only given like that info. So a side and I don't know and a side and a side. Now I'm given extra. Should that complicate things? Absolutely not. What I like to do is when I'm given 2 similar figures and I'm being asked to find the missing side length, I like to make a proportion of the big shape to the small shape. So big over small. I pick a side on the big shape that I know I have the corresponding part to. So let's use what looks like a hypotenuse, even though I know it's not. I'm going to choose 53 or 63 on the big, which matches up with 54 on the small. So 63 over 54. Now, if you're like, well, do I do the same thing with 56 and 48? Nope, I don't need them. Don't need them at all. Just extra information. I care about what that question mark is, and I'll just call it X for now. 35 over here matches up with I don't know over there. So 35 on the big is going to match up with X on the small. Now I have a proportion. And when you do a proportion, you do crisscross applesauce. So 54 times 35 is, of course, 1,890. I did that all in my head, and I didn't pause the video so I can look it up. Now I put an equal sign there, and I do the other diagonal, 63 times x, which is 63x. In order to get x all by itself, you divide by 63 on both sides, of course. And I absolutely know that this is, of course, 30. So 30 equals x, x equals 30, but I'm not even going to circle x because x isn't even part of my original problem. The figures are similar. Find the missing side length. The missing side length is 30. Okay? That's how it's done. The polygons are similar. Find x. Now, my job is to find that x value right here. I'm given 2 similar figures. I'll call you big shape. I'll call you small shape. Whenever I'm being asked to do any kind of solving with similar figures, I like to create a proportion with the big small matching, or the big side, big triangle. It'd be nice if I knew how to talk. Matching up with the small triangle. Of course, I said it's big small because I have rap music on the mind. Now, I definitely care about this x right here. So I need to make sure I match 63 up with that guy. So on the big, I have 63. And on the small, I have 8x minus 2. I'm going to set that equal to, well, let me see here. I have 49 and I have 49. But I can't use this 49 because I'm not given any information down there, so that extra 49 is useless. So I'm going to choose this 49 on the big over that 42 on the small because they match up. Now I have a proportion. And when you have a proportion, you're going to do crisscross applesauce. Pick any diagonal and multiply them together. 63 times 42, of course, is 2,646. No calculator needed here, just my mind. Now, over here is going to be slightly different. I have 49 times 2 things, and so whenever you see that, you have to do distributive property and group that 8x minus 2. So my next step is do nothing here. but distribute that 49 to 8. Now 50 times 8 would be what, 400? So 49 times 8 would be 392. I'm just going to sneeze quick. Achoo. Now that was correct. And so don't forget the x. 49 times 2, negative 2, is negative 98. I have a two-step equation now. So I'm going to add 98 to both sides, add 98 to both sides, and cross you out 2,744. That's going to equal 392x. I've heard of P92x, but 392x, that's different. Divide both sides by 392, divide both sides by 392, and I think it's 9. It's not, it's 7. I was just joking with you guys. Cross that out. X is going to equal 7. So I'll put that right here. X equals 7. Yeah, so there you have it. A little bit of extra information there to throw you off. A little bit of extra information here to make you do distributed property. But, similar figures, finding missing sides is all pretty much the same. You just set up a proportion using what you have. Don't do too much. Crisscross applesauce, do a little bit of math, and then you're donezo. Funzo. The polygons are similar, find x. Now, I'm not given a ton of information, except for the fact that the scale factor from A to B is 5 to 6. So I'm going to compare A to B, which I know is 5 to 6. On A, I have 3x plus 11, so I'm going to match that up with 3x plus 11, and on B, I have 42. So this is no different than a regular old find the missing side of these two similar triangles if we were given information. In fact, if I wanted to, I could have made U 6 and I could have made U 5 and made U 6, and the problem would end up being the same anyway. All right, so crisscross applesauce, whenever I have a proportion, you always multiply diagonals, make an equal sign, and then multiply the other diagonal. So we'll do 5 times 42 first, which is 210. Yeah, that looks right to me. We're going to set that equal to 6 times 3x plus 11. Ooh, in parentheses, whenever you have a group and you do proportions, you're going to have to do distributed property. Don't forget. So 210 doesn't change. 6 times 3x is 18x. And 6 times 11 is 66. Now I have a two-step equation. Subtract 66 from both sides. Subtract 66 from both sides. Cross U out. And you're looking at 144. That equals 18x. Now it's a one-stepper. Divide both sides by 18. Divide both sides by 18. And x is going to end up equaling 8. So there you have it. I believe this is my fourth find the missing side of a similar triangle type problem. All of them are the same. You just set a proportion, crisscross applesauce, do some distributed properties sometimes, and then take it from there. That's it. The polygons are similar, find x. Now, this is what we have here, and it's not as obvious as what we have. In previous problems, we're so used to seeing something that looks like this and something that looks like this, and then you match things up, crisscross applesauce. That's not what we have here, except it kind of is. I have that triangle living inside of this triangle right there. And if I wanted to, I could rip this apart and write down as much information as I need based off of what I just did. That red triangle was 36 right here, 27 right there, and -4 plus 4x right there. That big triangle was 64 all the way across. And if you're like, what about that part? I don't care about that part. It was 72 and 96. And now what I have is two separate triangles. It's, that used to be one big triangle with a little triangle inside of it. Now, whenever I'm finding similar triangles or missing side of similar triangles, I like to compare the big to the small and make a proportion. We have extra unnecessary information. First off, I definitely have to find x. So I'm going to make sure if I'm going to compare the big over the small that I first start out by comparing 64 over negative 4 plus 4x. Definitely have to do that first. Now, if you're wondering, all right, so what other sides do I do? It doesn't really matter. I could do 96 over 36 or 72 over 27. It doesn't matter. So I'll do 96 over 36 because it doesn't matter at all. Now I have a proportion, and whenever you have a proportion, you do crisscross applesauce. So we are going to multiply negative 4 plus 4x times 96. And when you do that, you have to make sure you set up a distributed property problem because this is two separate things being added together. Negative 4 plus 4x. Then you have an equal sign, and you multiply these two numbers together. 64 times 36 is 2,304. I did that in my mind. Now I distribute. 96 times negative 4 is going to be 384, negative 384, plus 384x equals 2,304. If I add 384 to both sides, that gets me 384x equals 2,688. Divide both sides by 384, and I think it's 8, but let me go off to the side here and double check. Glad I did, because it's actually 7. Whew. But that's how you do it. A triangle within a triangle, just view it as two separate triangles. Rip it apart if you have to, which I did, and you're good to go. The polygons are similar. Find the missing side length. The scale factor from A to B is 5 to 6, and I have, I don't know, but it matches up with 30. So whenever I'm being asked to find the missing side length of similar polygons, whether it's triangles or in this case a quadrilateral, the rules don't change. It's asking me to do A to B. So I'm going to set a proportion, which is a fraction equaling a fraction, giving me this information. A to B is 5 to 6. That's going to be equal to A is, I don't know, so I'll call you X, over matches up with 30. Now, when you have a proportion, you do crisscross applesauce, which means you multiply diagonal numbers. Doesn't matter which one you start out with. 6 times x is 6x. Then you drop down the equal sign and multiply the other diagonals. 5 times 30 is 150. Now I have a very simple two-step equation. Just kidding, one-step equation. And my one step is to divide both sides by 6. And 150 divided by 6 is 25. So there you have it. There's my x. I really shouldn't circle x because x wasn't in the original problem. I really should say just 25. I don't think you'd have a teacher that would mark you wrong. But if we really wanted to be specific, we would just say the missing side is 25. And there you have it. State if the triangles are similar. If so, state how you know they are similar and fill in the blank. What do they mean by state how you know? Well, there's 3 ways that you can prove two triangles are similar. There's SSS, there's SAS, and there's AA. Now, SSS means, is there a way that you can show that that side over that side, so like A over B equals that side over that side, so C over D, which also equals that side over that side, which is E over F. Now, if you're wondering what are these letters? This just means like that side over that side is the same as that side over that side, which is the same as that side over that side. A, C, and E are on the same triangle. B, D, and F are on the same triangle. So that's what SSS means. It's not the same as the SSS for triangle congruence. You're not looking for exact numbers, you're looking for a ratio. SAS means you're only going to pick two sides and match those up, but you're also going to see if two angles are congruent. AA is if two angles on one triangle are congruent and another pair of angles are congruent, that means automatically the third angles are congruent. But we don't care about the third angle because all I need is two. So what do we have here? Well, I'm not given any information about angles, which means I can't use either of these two, so I have to go with SSS. So what I need to do is I'm going to compare big to small. I always compare big to small when I can. Okay, the longest side is 84, which matches up with 14 on the smaller one. So if I'm doing big to small, 84 is the longest side. That is going to go over 14 equals. Now I'm going to do the same thing again. I'm going to choose the middle one, 72, which matches up with the middle one over here, 12. So 72 over 12. And I'm going to do it with the third side because SSS means you have to do it with all three. 48 over here matches up with 8 over there, 48 over 8. Now I simplify each fraction and see what I have. 84 divided by 14 is 6. 72 divided by 12 is 6. 48 divided by 8 is 6. Since all of these fractions equal, these are similar. And they're similar using SSS. So state if the triangles are similar. Yes. If so, state how you know. SSS. And fill in the blank. CBA is similar to, well, I have to make sure that I'm good here. C matches up with the F over here. How do I know that? C is in between red and black. F is in between red and black. C matches up with F. B is in between green and black. G is in between green and black. So G. And then the only ones left are H. So these were similar. SSS was the reason. And triangle CBA is similar to triangle FGH. That little squiggly means similar, different from congruent. State if the triangles are similar. If so, state how you know they are similar and fill in the blank. If I want to see if things are similar, there's three ways that I can do that. I have SSS, which means something on the big side needs to match up with something on the small side, and the other thing on the big side needs to match up with another thing on the small side, and another thing on the big triangle needs to match up with something on the small triangle. That's SSS. I also could use SAS, which is, are two sides proportional and are two angles congruent? If so, SAS. Or I could use AA, which says, are these two angles the same? Are these two angles the same? Oh, well, then the third angles are going to be the same, AA. Now, this is what I'm given. I'm given two sides, and that's it. Here's the other thing, though. I'm not given this, but I know that those are vertex angles, which means these are the same. So what I can use is SAS. But I can't just be like, it looks like SAS, I'm done. No, I have to check my work. Okay, now MV and 28 match up. I always like to do big to small. So 28 on the big has to match up with 14 on the small. Very good. That has to match up with 49 over 8. Now, 28 over 14, 28 over 14 is 2. 49 over 8 is definitely not 2. So are these similar? Are they? No, they're not similar. If so, blah, 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 blah. These are not similar, therefore I'm done. They're not similar because even though SAS looks promising, the proportions are not the same. And this makes sense. I mean, if you just look at the picture, I mean, no way. Not even possible. I mean, these two just like, no way. Given JI is parallel to KH, so you and you, they're parallel. Great. I need to prove that JGI is similar to KGH. Now, that shape means similar. Similar is different from congruent. Congruent mean they were exactly the same, exactly. Similar means they're the same shape. It's just one's bigger than the other. And there's three proofs or three theorems that we use for this. A means if I could show that two angles are exactly the same, then I have myself similar triangles. And if you're like, why not the third angle? Because if you can show that two angles are the same, then the third angle is going to automatically be the same. Another one is SSS. And you might be thinking, isn't that a congruency one? Yes, it is. But what we're talking about here is ratios. So if I have a triangle with sides A, B, and C, and if I could show that it's congruent, or if the ratio is congruent to sides D, E, and F, then I have myself SSS. The third one is SAS. So if I could show that two sides are proportional, and if I could show that two angles are congruent, then I'm good. So what I'm going to do here is see what I have, see what information I have. I have the fact that JI and KH are parallel. Now that would make J and K congruent because they're corresponding angles. What that also means is H and I are congruent because those are corresponding angles too. So right then and there, I have my double A. Okay, and I can prove that these two guys are similar. So not a lot to show. In fact, this might be only 3 steps, but sometimes with these similar ones, you're not going to show a lot of steps. The similar proofs are a whole lot friendlier than the congruent proofs. So let's start out by saying my given that JI is parallel to KH, and that's my given. That means that the measure of angle GKH is equal to the measure of angle GJI. Also, the measure of angle GHK is equal to the measure of GIJ. G.I. Jane? Nope, close. G.I.J. Ooh, don't make a G.I. Jane joke around Will Smith. He'll slap you. Because of the Oscars. Why is that? That is the definition of corresponding angles. Now, if you have a really mean teacher that doesn't accept AA, which is ridiculous, and they force you to do AAA, AAA, then the third angle would be G is congruent to G using the reflexive property. But like I said, we don't need that because we only need 2 angles are the same. And so since 2 angles are the same, we have enough information to say that triangle JGI is similar to triangle KGH. And that is using the AA theorem. Okay? So again, similar proofs are a lot friendlier. They usually take less steps. But we're done. That's how I did it. Given MQ is parallel to OP, so MQ, OP, I need to prove that MNQ is similar to PON. This is similar. Remember, similar is not congruent. It can be, but it's not. Okay, so with congruent, we had like SSS, SAS, ASA, AAS, HL, HA, LL, LA, and you're like, well, which one should I use? Not so many. See, with similarity, we only have 3 ones that we need to worry about. Showing 2 angles are congruent, or we could show that the sides are proportional, which means you have 3 fractions equaling each other, or you can show that 2 sides are equaling each other as far as proportion goes, and 2 angles are equaling each other. Now, let's see what I can do here. I have the fact that these guys are parallel. Since they're parallel, I can say that you guys are alternate interior angles, so you're the same. And let's mix it up, because I already did one where I did... No, I didn't. I take it back. Let's just do this. I was going to do vertical angles, but I changed my mind mid-sentence. So because that these are parallel, these alternate interior angles are going to be congruent, and these alternate interior angles are going to be congruent. If you wanted to be like, well, sir, I wanted to do these alternate interior angles and vertical angles, will that work? Sure will, because that follows AA. I'm not giving really a whole lot of information about my side, so I'm not going to bother with these guys right here. I'm sticking with AA. So what I'm going to do is I'm going to state my given. I'm going to say that these 2 guys are congruent by definition of alternate interior angles, and then my last step 3, I could say that they're similar using AA. So number 1 is the given. Side MQ is congruent to side OP, and that's my given. Let's use the right colors. 2, I could say that angle QMP, the measure of angle QMP, is equal to the measure of angle OPM. Also, the measure of MQO is equal to the measure of POQ. And again, my reasoning for that was the definition of alternate interior angles. Oh, these angles are the same? These angles are the same? And all I have to do is prove that they're similar? Then they're similar. M and Q is similar to PON. And that's using AA. And that's it. Given AB over DE equals BC over EF equals AC over DF, I need to prove that these 2 guys are similar. All right, well, there's 3 ways that you can prove that triangles are similar. Okay, you could use the angle-angle method. If you could show that 2 angles are congruent and 2 more angles are congruent, I could use the angle-angle method. I could also use the SAS method. The SAS method says that if you could show that 2 sides are proportional to each other, side over side equals side over side, and if you could show that 2 angles are congruent, then you have SAS. The third option is SSS. And SSS, or if you're a snake, says that if you have a side over a side, corresponding sides, equals a corresponding side equals a corresponding side, then you have similar triangles. And you might look at this and say, doesn't the given tell you pretty much the same thing as this? And I would look at that and say, why, yes. Why, yes, it does. And if you're thinking, so this proof is state your given and then state your proof, and it's only a 2-stepper? Yes, Yes, it is. Similarity proofs are not that bad compared to congruent proofs, and this is one of them. This is a two-step proof. That was supposed to be a circle over 1. AB over DE equals BC over EF equals AC over DF given. Oh, look. These proportions equal that proportion, and we're done. ABC is similar to DEF. And that's using SSS. Very, very, very basic. Very, very, very easy. That's it. We're done. Given angle A is congruent to angle B, so these guys, I need to prove that Abe is similar to BCD. So similar is a lot friendlier than congruent. Similar, I have 3 main theorems that I can use. If I could show 2 angles are congruent, I'm done. If I could show that 2 sides are proportional, so if I say that side over that side is equal that side over that side, and if I show that 2 angles are congruent, I'm done. Or I could show that that side over that side equals that side over that side equals that side over that side, and then I'm done. I look at this and I see an angle already. So my thinking is, can I do a whole lot with the sides? No. But you know what else I can do? I could show that angle C is congruent to itself using the reflexive property. So if angle C is congruent to itself, and if I have 2 angles already, it's AA. For some reason, I didn't copy and paste the statements and the reasons 2-column proof thingy, so I'm going to do that right now. Statements, reasons. And what I'm going to do is I'm going to state my given. I'm going to say that the measure of angle C is the same as the measure of angle C. And then that's it. That's all I need. And then by AA, these 2 guys are similar. So statement number 1, the measure of angle A is congruent to angle B. Given. 2, let me get the right colors. I could say the measure of angle C is congruent to the measure of angle C, and that's the reflexive property. Anytime you say something is equal to itself, that's the reflexive property. Now that I have these 2 angles and these triangles are the same, and this angle is exactly itself, that's angle. I've done enough. Okay, triangle Abe, rest in peace, Prime Minister of Japan, is similar. Ooh. In being reverential to the deceased, I accidentally screwed that up. ABE is congruent, similar to BCD, and I used AA. Or as the Fonz would say, A. From Happy Days. It was a show from like the 70s, I believe. Took us back to when things were happy. Like and subscribe. Find X. What I have is a triangle, that is a right triangle, and I have 2 other right triangles living inside this. Now, there's a way that you could set this up and solve it using proportions, but I'm going to show you a different trick called the geometric mean. You may have heard of the arithmetic mean. This is the geometric mean. If you are given a big right triangle and you have the altitude and your job is to solve for the altitude, and that's what I have here. If I were to take this triangle that's 100 whatever's long and lay it flat, okay, like that, I can see that X is my altitude. What I know is one of those lengths is 36. Now, let's take that out and pretend like we don't know that. Let's pretend we don't know any of this stuff, all right? Get rid of these numbers. Okay, there is a little shortcut using the geometric mean. If you are trying to find the altitude of a right triangle, what you do is you label part of this hypotenuse A and the other part B. The altitude splits it. And you set up a proportion A over X equals X over B. That's the geometric mean. Now, I have something very, very, very similar. I have one of these guys is 36. I showed that over here. I don't have the other guy. But what do I know? I can find the other guy by doing 100 minus 36, which is 64. So I would let A or B, it doesn't really matter because you're just going to end up doing crisscross applesauce anyway. I'll say 36 over X equals X over 64. Now that I have a proportion, I can do crisscross applesauce. Multiply two diagonals together, X squared, and multiply these diagonals together. That gets you 2,304. Take the square root of both sides because that's how you undo a square. Now, usually you attach a plus or minus to your number here. However, I'm not going to do that because that implies you're taking a negative side length, which doesn't make sense. What I do get is the square root of X squared is X. And the square root of 2,304 is 48. I knew that right off the top of my head. Didn't use a calculator. Didn't use a calculator at all. But this is using geometric mean. There's other ways that you could do this by using similar. I mean, if I wanted to, I could rip this apart and pretend that I have a small triangle and a big triangle and do similar triangles like I've done 1,000 times on this channel. But here I'm doing geometric mean to show you something new. Find X. What I have here is I have two parallel lines and pieces of that parallel line. There are several ways that I can set this up. But one way that I can set this up is I have a big triangle with a small triangle living inside of it. My big triangle is this whole thing. My small triangle is this little tiny piece right here. And so I'm going to set up a proportion comparing the big triangle to the small triangle. So on the big triangle, I have 45. That matches up with 5x on the small triangle. Okay. On the big triangle over here where I'm given some information, I have 36 on the big. That matches up with 20 on the small. Now that I have a proportion, I could do crisscross applesauce. Take two diagonals and multiply them together. 45 multiplied to 20 is 900. 5x times 36, 5 times 36 is 180. So 180x. Divide both sides by 180. And x equals 5. So this is not too different from regular old find the missing side of similar triangles problems that we've done before. It just gives you information about parallel lines, and parallel lines mean you can do some special stuff with it. But that's it. We're done. Find x. What we have here is we have three parallel lines and two lines that are not parallel that cut through it. Now, there's a little rule, and I'll try to draw this similar to what we have here. It's obviously not going to be the same. But there's a little rule that says, let's call you A, let's call you B, let's call you C, let's call you D. If these three lines are parallel, then what we could do is set up a proportion A over B equals C over D. Now we have something very similar, but it's incomplete. See, I have 25 here. I don't have that chunk, so 25 would be C. I don't have A. Oh, but you know what I could do? I could do 35, this whole thing, minus 25, which is 10. Okay? Here, I have 22, but I don't have this part right here, but I do have the whole thing. Now, if what I did to find this chunk over here was do the whole thing minus 25, then why don't I do the whole thing minus 22? In other words, 7 plus 14x minus 22, which is 14x combined like terms, negative 15. So I'll call you 14x minus 15. Now I can set up a over b, 10 over 22, equals c over d, 25 over 14x minus 15. So let me erase this chunk right here and do just that. 10 over 22 equals 25 over 14x minus 15. We have a proportion, so you could do crisscross applesauce. 22 times 25 would be 550. We're going to set that equal to 10 times, a group, so I have to set up distributed property, 10 times 14x minus 15. So my first step in this problem is to do distributed properties, so 550 just drops down. 10 times 14x is 140x. 10 times negative 15 is minus 150. Now we have a two-step equation. I can add 150 to both sides. When I do that, I get 700 equals 140x. One more step. Divide 140 from both sides, and x is 5. Now, there's several ways that you could do this. There's several proportions that you could use, but I'm using the rule that we're given, and that rule is you have 3 parallel lines, that over that equals that over that. I could also have done 10 over 25 equals 22 over 14x minus 15. It'll all work out anyway because crisscross applesauce gives you a little bit of maneuverability. And that's it, we're done.